Exercise 1.3, question number 1. Prove that root 5 is irrational. In this question, we have to prove that root 5 is an irrational number. So in this question, what we will have to do, firstly we have to consider the given number as a rational number. Then at last we will contradict our statement. That is, after solving this, we will prove that our assumption was wrong. So it will automatically prove that the given number is an irrational number. Okay. So firstly, consider that root 5 is a rational number. So if it is a rational number, we can express this in the form of p upon q, as it is given in the rational numbers definition that any number which can be represented in the form of p upon q is a rational number, where p and q must be integers and q does not equal to 0. Okay. Now, on squaring the equations on both sides, under root of 5 square will be 5 and p upon q square will be p square q square, which implies p square is equal to 5 into q square. Now, as from this equation we can see that this p square will be divisible by 5. Okay. So if any number's square is divisible by a prime number, then that number should also be divisible by that prime number. This is a theorem, okay, which says that if square of any number is divisible by a prime number, which is 5 here, then that number should also be divisible by 5. Okay. So if here p square is divisible by 5, then it is also obvious that p should be divisible by 5. So now we will consider p upon 5 as n. Okay. From here we will get p as a multiple of 5. Okay. P is equal to 5 into n, that is p is a multiple of 5. Now on putting the value of p is equal to 5n in the above equation 1, where p square is equal to 5 into q square, we get 5n square is equal to 5q square. Now 5 square is 25 and n square is n square. Okay. So now this will be equal to 5q square. From here we will get this 5 will cancel this 25 5 times. So 5n square is equal to q square. So again this q square is divisible by 5. Okay, as q square is a multiple of 5, so q square will be divisible by 5. Now according to theorem, if the square of any number is divisible by a prime number 5, then that number should also be divisible by 5. So if q square was divisible by 5, so q must also be divisible by 5. Now we know p and q both are divisible by 5, so these two numbers have a common factor as 5. And we already know if it is a rational number, so this p and q must not have a common factor. Okay, so as we have assumed it as a rational number, so our assumption is wrong. So it is a contradiction, hence root 5 must be a irrational number. And this is the proof of this question. Moving to next question. Question number 2. Again in this question we have to prove that 3 plus 2 root 5 is an irrational number. So in this question we have to prove that 3 plus 2 root 5 is an irrational number. So firstly we will consider it as a rational number. So we can express this in the form of p upon q, where p and q are integers and this q does not equal to 0. Also these two numbers does not have any common factor. Okay, means the SCF of these two number must be 1. So now if I move this 3 on another side of equal, then it will convert into minus 3. Okay, so it is a rational number. Now if this 2 is here in multiplication, it will come and divide on another side. So I will get root 5 is equal to p upon 2q, also minus 3 upon 2. Because this 2 will come and divide in both of these terms. So now here we get root 5 is equal to p upon 2q minus 3 upon 2 as a rational number. But as we have seen in the first question that this root 5 must be a irrational number. We have already proved that root 5 is a irrational number. So our contradiction goes wrong, and what we have supposed that 3 plus 2 root 5 is a rational number is wrong. So it automatically proves that 3 plus 2 root 5 is a irrational number. Moving to question number 3. Question number 3, we have to prove these numbers as irrational. Now again we have to prove that 1 by root 2 is a irrational number. Okay. So firstly we will consider that 1 by root 2 is a rational number. So again we can write it in the form of P upon Q, where P and Q are integers and Q does not equal to 0. Also P and Q can't have any common factors, so their SCF must be 1. Now on rationalizing 1 upon root 2, we have to multiply 1 upon root 2 by root 2 and root 2 both in numerator as well as in denominator. So we will get 1 into root 2 equals to root 2. Also in the denominator we will get root 2 into root 2, which is equal to 2. Now we get, after replacing this 2 on another side, this will convert into multiplication. Now we get in the third step as root 2 is equal to 2 into P upon Q is a rational number. But as we already know that root 2 is a irrational number, we can prove that root 2 is a irrational number. So our assumption is wrong and we have contradicted our assumption. So hence it is proved that 1 by root 2 is an irrational number. Moving to second part of this question. Question number 3, part number 2. Now we have to prove that 7 root 5 is an irrational number. So firstly we will consider 7 root 5 as a rational number. So we can express this in the form of P upon Q, where P and Q must not have any common factor. Also P and Q are integers and this Q does not equal to 0. Now by replacing this 7 this side, it will come in divide. So we get root 5 is equal to P upon 7Q as a rational number. But we already know that root 5 is an irrational number. We can prove that root 5 is an irrational number. So our contradiction is again wrong and hence it is proved that 7 root 5 is a irrational number. Okay, moving to next question. Question number 3, part 3. Question number third part, 6 plus root 2. We have to prove this number as an irrational number. Again we will consider this number as a rational number. Now we can express this in the form of P upon Q, where P and Q are integers. This Q does not equal to 0. Also these two can't have any common factor. Okay, now this 6 is here in plus, so on moving to another side it will convert into negative. Now we get